Okay, AP Stats, we're going to finish up these problems here. So next one, suppose the mean grows over time. How big would it need to get for 5% of the population to have an IQ above 150? So let's draw the picture. All right. And I don't know why it changed colors there. That was weird. Okay, so, oh shoot, I don't even know what to put in the middle here. It's the mean, but I don't know what the mean is. Okay, this looks kind of tricky here, right? I mean, you can see how, okay, this is a little bit more involved. Okay, well, let's just draw the picture. So we want 5% of the population to be above 150. So we want that to be 5%, and we want that to have a value of 150. We assume the standard deviation stays the same, but the mean is growing over time. I'm sorry, it doesn't state that, but that's the assumption I made when I wrote this problem. Okay, well, we know the percent, so going to the flow chart, starting from the percent, we're working backwards. We're not going from z-scores to percent. We're going from percent back to z-scores, inverse norm. So we got to use inverse norm. Well, I know what the 5%, so I can use that. I can do that. I can go distor inverse norm, and I want 0.95 to be to the left because I want to be at the spot where there's only 5% above you. Okay? Down one more. There we go. And enter. Okay, that just puts it together so it's ready to do, and then I hit enter, and it does it. Oh, 1.645. We already knew that no matter what the problem is, the z-score is 1.645. Okay. Well, then we're supposed to use the z formula. So z equals value minus the mean over the standard deviation. Okay, what do I know? Well, I know the z-score. 1.645 equals. This time I know the value. I know I want 150 to be the value, the IQ value that we're talking about. The mean is what I don't know. And I know the standard deviation is the same as it was before, so standard deviation is 12. Oh, this is just an algebra problem now. I could multiply both sides by 12. I'm going to stop scrolling because this is just algebra, so I'm just going to do this with mine here because it's a little easier. So I'm doing 12 times 1.645. And I get 19.74 equals 150 minus mu. Yeah, that's it. Okay, so then I could add the mu over to this side and subtract 19.74 over. So 150 minus 19.74 gives me 130.26. I'll round it to 0.3. Okay, so if your mean is 130.6, 0.3, whoops, don't know why I said 6. So if your mean is 130.3, then, and the standard deviation is still 12, then an IQ of 150 is going to have 5% above it. So this is the tricky part, is in order to be able to work this out, I didn't know what the mean and the standard deviation was, so I had to go to z-scores. I think I'm going to stop there, but I've got some time I left some time on the clock, so we could just kind of take a look at some of the problems here on tonight's homework. So first you had to do, on page 106, 107, you had to do 23 and 27. So they're going to give you information about a situation, and then they said, suppose that, or I can expand that there. Suppose every teacher is given a 1,000 raise. This is tying into that stuff we talked about, where if you add 1,000 to everybody's salary, what is that going to do to the shape? What is that going to do to the mean and the median? What is that going to do to the standard deviation in their quartile range? Now, remember, when you're adding, the values are just going to go up together, so that's not going to change the shape at all. And then you say, okay, does adding change the mean? And also the median is going to be the same thing, because it's, the mean and the median are both going to do the same thing. I'll just say that. And then standard deviation and IQR, those are measures of spread. So when you add 1,000 to everybody's data value, does that change the spread? And then in 27, they say, okay, well, hold on a second. Suppose instead we give people a 5% raise instead of $1,000 raise. So you'd multiply everybody's salary by 1.05. That gives you a 5% bonus. What will that do to these things? So you can see how it's the same kind of question as we saw. Does adding and subtracting change the mean? We focused on mean and standard deviation in class to keep it simple, but really it's any measure of center and any measure of spread. And then does multiplying and dividing change any measure of center and any measure of spread? Cool. Let me pause and let me go to the other page. Okay, this is page 139. So first one here, this is just going back to the whole thing we talked about with regard to density curves. For the question of what height must the density curve have, remember a density curve always has an area of 1 underneath it. So since you know how wide it is, you can figure out how tall it is. And then it asks a couple of questions here. This is just getting at density curves, not a huge thing, and not tied. That was tied to last class. Next one is, what's the next one? 48. Okay, so 48. 48 is looking at a normal model and just making a sketch and doing it accurately given the mean and the standard deviation. Not a problem. What's next? 52 and 54. I'm just kind of like, I have a little time here, so I thought, give you a sneak preview. Maybe this will help you out. 52. Now in 52, they say keep using the empirical rule. And so use the empirical rule. That's a 68, 95, 99.7 rule. And you should be able to work out some of the stuff. I know that it says a player with a batting average of this is at about what percentile, so it might be a little bit off and not perfectly at at one of the 1, 2, and 3 standard deviations from the mean. But the expectation here is you just use the empirical rule. You don't need the calculator for these ones, or you don't need it to do norm CDF or inverse norm. Okay, just checking. That was 52, 54, and then 54. Now in 54, they say it's 200. It doesn't say use the empirical rule on this one. So I think at this point, now you should think about using the norm CDF. You know what the mean is, you know what the standard deviation is, so you can draw the curve, and you want to know a player with a batting average of below 200, what percent of players have a batting average below 200, then you're going to say, okay, I need to figure out that z-score, and then use norm CF to find the area. Norm CDF to find the area. 62, 64. How am I doing on time? Doing great. 62. Classic norm CDF. And this is all norm CDF problems because it's having you figure out what percent or what proportion, same thing basically, are in each range. Now, what I'd say on these is you could draw one model and that's okay. Like you don't have to draw a separate model for each one because it's the same model for all three. But make sure you work out the z-scores on each one of them. Man, I want you guys to be awesome on z-scores. Last year they'd use the calculator too much, and as a result, they didn't get the z-score thing down as well as I wanted them to. And last year was weird. And so I really want you to just be automatic on finding z-scores and understanding what they mean. And then finally on 64, it's the same situation. It's Djokovic again, and it's now they give you the percentile, and now you have to work backwards to figure out what his serve speed is. So you see how that's that working backwards thing. So it's here's the percent, you work out what the z-score is, and so you work out the z-score, and then use that to figure out the value. So the tennis stuff is all very much norm CDF and inverse norm using that flow chart. Why don't I just, for the last couple minutes here, just remind you on the flow chart what we're talking about. In a normal model, sometimes you're right on the values. I could say how many people order a sodium meal order a Chipotle meal. I love Chipotle. Chipotle's great. Below 1,500 milligrams of sodium. And then you can use this idea like, oh, okay, I know that there's 68 there. And so that's 34, and that's 34 because 68. And so, okay, then I can work out what this is because I know 50% is to the left there. So, so if they give you one that allows you to use the empirical rule, you're set. You can just use the empirical rule. But sometimes that's not true. And so early in class, we got this idea that we can instead use z-scores to handle things, because z-scores, we know, always have a mean of 0 and always have a standard deviation of 1, no matter what the data set is. And that's actually true no matter what the shape is. The thing that we need it to be normal for is to use the norm CDF and inverse norm button. So you could always work out the z-scores, but unless you knew it was a normal model, you couldn't do this step to work out percents. So if we start with some normal situation, we can always convert the numbers there to the standard normal model, and then we can use the standard normal model to work out the percents, because we've got this handy dandy calculator and it can work out the percents for us. And then if they start off with the percents and we know it's a normal model, we can work backwards to say, well, what would the z-score be? And then, I mean, that's the conversion between this one and this one, is that great Z formula, is that, how you get back and forth between, like if I tell you what the z-score is and I ask you what the, how many milligrams of sodium that is, or if I give you a milligrams of sodium and say, what is the z-score? Either way, it's that formula, z equals the value minus the mean over the standard deviation. Man, that thing's important. Okay, I'll stop here. Hope this helps out with the homework. And I know it's a lot that we're taking on right now, but keep it up and ask questions when things aren't clear. Ask the questions in class. We'll make sure you get them. Or you can come in and see me. I'm always available during lunch. I try to keep my lunches free, and so just let me know ahead of time so I don't go off and chat with some other teacher or something like that, just to hang out. And so just let me know you want to come, and then come on by, and I'm happy to talk with you. Okay? Take care. Have a good night and a good Tuesday night, and we'll see you Wednesday. All right. Don't forget to dress up.